This Zoom session is being brought to you by the Fractal Horizon. Okay, for today, 2.5 and 2.6, about functions and shifting their graphs. I always think of this thing about functions as more like, shall we say, mathematical grammar than mathematical vocabulary. It's a way of talking about things. Okay, a function. It's a rule which takes an input x and from it computes an output called f of x. So, and the set of possible inputs is called the domain. And function moves something from takes something from the domain and yields something in the range. That's the set of all possible outputs. So here are some functions. X plus 17, that adds 17. 23x, okay. X to the third power, 3 to the x power, okay, functions. The graph of a function is a set of points with coordinates x by f of x. So we're basically saying that y, the second coordinate, equals f of x. So you'll generally have an equation, maybe make a table, and from the table, write a graph. So for example, the equation y equals x squared, well, for various values of x, -2, -1, 0, 1, 2, we calculate 4, 1, 0, 1, 4. And then you plot those points. -2 by 4 goes here, and -1 by 1 goes here, and 0 by 0 is here, and 1 by 1 is here, and 2 by 4 is here. I've seen people, so here are 5 points, but of course there's infinitely many points on a graph because it's a continuum. I've seen people try and graph this and they draw this thing with a pointy end. That's not quite right because, for example, -1/2 yields a quarter, +1/2 yields a quarter. It actually kind of rounds up to a flat point at the bottom. And of course, if you have a graphing calculator, you could push a few buttons and see a graph on the calculator. Now, I mentioned the domain and range of a function, the possible inputs and the possible outputs. If this here is a graph of a function, and if you project that graph onto the x-axis, those are the possible inputs and therefore the domain. If you project that graph onto the y-axis, those are the possible outputs and therefore the range. Now, if x is a value, then f of x is computed to be a single value. So for any x value, there's at most one y value, at least on the graph of a function. So therefore, any vertical line, a constant value of x, meets the graph of a function at most once. That's called a vertical line test. For example, this, the kind of a wiggly thing, is the graph of a function because every vertical line meets it but once. This is a graph of a function, same reason. Although you'll notice that the domain of this is only the positive numbers. It's not defined for the negative numbers. This is not the function, a graph of a function. Here's a vertical line that meets it twice. Nor is this, because here's a vertical line that meets it 3 times. In a sense, you could say that, for example, the upper half of this circle is one function and the lower half is another function. So it's really 2 function graphs. Similarly, you could talk about this being a function and this being a function and this being a function. Now, okay, so function graphs include this. Y equals ax plus b. Its graph is a straight line, so this is called a linear function. Y equals ax squared plus bx plus c. That will generally be the form of a U-shaped curve, pointing up, say, or down, and narrow or wide, and intersecting the graph twice, or just once, or no times at all. Y equals x cubed is this n-shaped function. It's called a cubic. The reciprocal of x, 1 over x, y equals 1 over x, has a graph that looks like this with a couple of curious features. As x approaches 0, y approaches 1 over 0, which is infinity, which it never reaches. So this line, this graph, the graph of this, never quite reaches the x equals 0 line. So it's called asymptotic. And likewise, if x approaches infinity, the 1 over x approaches 0 but never reaches it. So it's also asymptotic to this horizontal line, y equals 0. Later we'll be seeing these two guys, exponentials and logarithms, very important functions. Here's y equals 2 to the power x. It starts small, then grows explosively. So this is an exponential explosion. Here, this is log base 2 of x. It looks like the graph of this flipped through the diagonal. That's because these are what are known as inverse functions. We'll get back to that later. So for some examples. Now you evaluate a function at a value by a substitution. So for example, if f of x equals 2x minus 3, then we can find f of 3 and f of negative 1 by substituting in 3 and negative 1 in for x. So f of 3 is twice 3 minus 3. After some calculating, it's 3. F of negative 1 is twice negative 1 minus 3. That comes out to negative 5. All right. All right. H equals 1 over x plus 3. H of 5 and h of negative 2 by substitution. H of 5 is 1 over 5 plus 3. That's 1/8. H of negative 2 is 1 over negative 2 plus 3, which works out to 1. I think I forgot to mention. Oh, I should have mentioned this before. We may have done this before, but in this function, ax plus b, when x equals 0, it goes the y equals b. So this point right here is at 0 by b. It's called the y-intercept. And a is the slope of this line. And have we gone over slopes yet? Well, if not, then we will. Anyhow, this is the slope-intercept form. And they ask, and so, okay, we'll find the function whose graph is a line, therefore this form, has a slope of 5, and it goes through 0 by negative 3. Okay, by the slope-intercept formula, the slope is a, which is 5. The y-intercept is negative 3 here. So y equals 5x minus 3. Here they ask for find the equation of a line through 1 by 7 and negative 2 by 1. All right. First, we need to find the slope. That'll be the change in y, 7 minus 1, over the change in x, 1 minus negative 2. You get 6 over 3. That's 2. I think oh dear, I'm not sure if we've gone through enough of this before. But okay, the equation of a line through 1 by, so by the point slope formula, it's y equals slope times x minus h plus 7. Because up 1 by 7 is here and here. Slope is 2 here. After some calculating, you get y equals 2x plus 5. Find the equation of a line through 1 by 2 and is perpendicular to the graph of y equals negative x over 6 plus 1. Now, this line here has a slope of negative 1/6. The perpendicular slope is the negative reciprocal. So negative 1 over negative 1/6, which is 6. So the line in question has a slope of 6 that goes through 1 by 2. So we use the point slope formula. The slope here is 6. 1 by 2 goes here and here. After some calculating, you get y equals 6x minus 4. And here we have the Fahrenheit to Celsius conversion table formula. Given a Fahrenheit degree is F, to find the Celsius degrees, you subtract 32 and multiply by 5/9. So if the Fahrenheit degree is between 78 and 77, what are the Celsius degrees? All right, fine. Well, if F is between 68 and 77, then F minus 32, you subtract 32 throughout. F minus 32 is between 36 and 45. And then multiplying by 5/9 throughout. 5/9 of F minus 32 is a C. 5/9 times 36 is a 20. 5/9 times 45 is 25. So between 68 and 77 degrees Fahrenheit is between 20 and 25 degrees Celsius.